You should know from previous videos that in any given reaction, the total number of atoms making up the reactant and the product does not change. So it follows that the total mass of reactants will be the same as that of the products, as mass is always conserved in a chemical reaction. But often in a reaction, not all of the products formed will stay in the reaction vessel. Some may be lost to the surroundings as a gas. You can see this effect simply by dropping an Alka-Seltzer tablet into a small glass of water. The bubbles or effervescence you can see is carbon dioxide gas produced by the reaction of the tablet in an aqueous environment, and if you look closely you can see the liquid in the glass slowly decrease in volume. It is losing mass, and this mass can be measured. Measuring the loss of mass as a reaction occurs is important because it can tell us the rate at which the reaction proceeds, which can be vital when it comes to producing chemicals in industry quickly and efficiently. On the other hand, measuring the total loss of mass once a reaction has gone to completion can tell us whether the experiment has been successful and whether the reactants are pure. So, how do we measure this loss of mass? Let's look at a simple reaction. Marble chips, that is calcium carbonate, react with hydrochloric acid to give calcium chloride, carbon dioxide, and water. Have you noticed that one of the products here, carbon dioxide, is a gas? So, if you were to add marble chips to hydrochloric acid in an open beaker, can you think how the loss of mass in this reaction might be measured? Pause the video and have a think. The answer is, you would carry out the reaction on a set of electronic scales, first recording the total mass of the beaker and all the reactants. Then you would add the marble chips to the acid in one go and immediately start a stop clock, recording the mass of the beaker at regular intervals. You should see it decrease over time as carbon dioxide is lost. You could then plot a graph of loss of mass versus time. To see how you can use this to work out the rate of a reaction, see this video, also on our channel. Now, here is a challenge for you. If you were to use 0.25 moles of calcium carbonate in an excess of hydrochloric acid, can you work out what would be the total mass lost once the reaction has gone to completion? This is tricky, so grab a pencil, paper and calculator and work through it slowly. Remember from the equation that each mole of calcium carbonate used produces 1 mole of carbon dioxide, and you are using 0.25 moles here. Then you need to work out the molar mass of carbon dioxide using your periodic table. Then, finally, use this formula to work out the mass. Pause the video now and resume when you have the answer. There were 0.25 moles of calcium carbonate used, and so 0.25 moles of carbon dioxide escaped from the reaction vessel. The molar mass of carbon dioxide is 44 grams per mole. That's 16 plus 16 plus 12. Then use this formula. Substitute the letters with the numbers that you have to work out the mass of carbon dioxide that is produced. So, the mass of carbon dioxide which escapes is 0.25 moles times by 44 grams per mole, which equals 11 grams. This is the loss of mass. Did you get it right? Chemists often find it helpful to do such calculations in advance. If you do an experiment like this in the lab and get a very different answer compared to what your calculations predict, this tells you there's a problem with the experiment. Your calcium carbonate might contain impurities, your equipment might be faulty, or you might be making a mistake in following the procedure. So, in summary, you can observe a loss of mass in a chemical reaction when one or more of the products escapes as a gas from an open vessel. You can measure the mass that's been lost by placing the reacting vessel on electronic scales and recording measurements at regular intervals. From this you can work out the rate of the reaction.